Recording.
All right. Good evening, everyone. This is our 241 project exploring the world of red wine by Mauricio, Luke, and I. So some of the things on wine composition is acidity and pH, sugar and alcohol, and sulfur compounds, and these all go into the making of wine and like how it tastes and all that stuff. All right. So exploring just like the relationship between the wine composition and quality. All has to do with density, acidity, and the alcohol level itself, and that kind of all goes into the quality of the wine itself. And then uncovering the correlations in wine composition. So same thing with like acidity and citric acid, acidity and pH, density and residual sugar, and alcohol and density. Like we have like different data sets that kind of go into all this and just the different relationships between these different wine composition like elements. Predicting wine quality through regression modeling. So we have simple regression, multiple regression, and ANOVA analysis, and we have these different tables on the following slides. The data like components are cyclochemical tests, and some of these include fixed acidity, voltile acidity, citric acid, residual sugar, and many more. Also quality rating, sample size, where we collected the data from, and the objective is to model wine quality based on cyclochemical tests.
Right now, I would be talking about how we analyze the data and like what was the thinking like when we were going about with the data analysis. So, potential for analysis with our data. First and foremost, correlation and causation. We have to establish that. Sometimes you see a correlation, but correlation does not always equal causation. So we must have a really good confidence interval to determine like the relationship between the two, and then predictive modeling, which we basically did using Python as well as like some languages to predict quality ratings from chemical properties as well as what we saw in the data. And then we had data transformation where we assess the need for normalization or transformation of the skewed variables. Like we did a couple of tests, like we did a whole range of tests, like choosing different types of plots for each data. Some of them worked, some of them didn't. And at the end, like we picked the stuff that worked and made it better by like also doing like data cleansing where we got rid of the outliers and also like accounted for those things. All right, moving on. All right, so analysis, right? So what statistical methods that we use? Obviously, we used like multiple regression tests analysis where we determine the relationship between the physiochemical properties as well as that of the wine quality, how good the wine is. And then the ANOVA analysis, which is the analysis of variance to test the significance of the individual variables that we observed, as well as a correlation analysis to measure the strength of association between each variable, and a diagnostic plotting, which included a normalized QQ plot for norm and a residual versus fitted value for like homoscedasticity. So yeah, moving on now. All right, now these are some of the data that we got, which is a histogram. You can see that this is kind of more like somewhat skewed. This is a skewed data, and based on alcohol percentage against frequency, this is one which we observed. Moving to the next slide. The histograms here. Previous slide, please. Again. Yeah. All right. Let's go on to quality versus density itself. So you can see here, which is a scatter plot, and here the scatter plot we expected to see like a negative correlation as higher alcohol content usually correlates with lower density. This comes from like academic research that already took place, and the data points are dispersed without clear downward trend you can see here, and no correlation coefficient is immediately evident, suggesting that this is a weak relationship here. Moving on. Yep. Now going on to like the multiple regression, which I already talked about before. So this is like fitted values against residuals. Here we analyze the residual spread across the range of the fitted values. So you can see here a perfectly hemoscedastic model which means that it would show a random spread across the zero line, which is a perfect hemodastic model without any desirable pattern. You don't exactly see a pattern. Our model, though, if you can observe here, reveals a slightly widening spread, right? Widening spread in residuals for fitted value between 10 to 12, hitting at potential variance issues that might be improved with transformation, which can be looked into for like future studies as well. Next slide, please. All right, here now the skew descriptive data. I paused before, right? I thought this data was like straight after the histogram, but now, all right, let's talk about this. The histogram here reveals distributional characteristic of each variance. Take, for example, the fixed acidity value, like you can see it here, right? Its distribution is right skewed with a long tail extended towards the higher acidity levels, which you can clearly see, I guess. Like it's the image is small, but I hope you can make out. And now let's try contrasting this to the pH histogram, which shows a more symmetric distribution, right? It's kind of symmetric, but it's also while it is symmetric, it's also kind of left skewed, peaking just below the neutral value of 7. So this is what we found with our data, and these are like the other data that we got. Some are symmetric, some are left skewed, some are right skewed, some are semi skewed as well. Next slide, please. All right, now coming into the most important thing, which is the correlation matrix. We created a heat map to illustrate the strength of the relationship between between the variables, which is basically the correlation matrix. For instance, like you can quantify the correlation between fixed acidity and that of citric acid, which you can clearly see here at about 0.67, a substantial positive correlation, right? Conversely, now the quality shows a notable negative correlation as well with volatile acidity. It's kind of cut off, but I hope you can make out at minus 0.39, right? And a positive correlation with alcohol at 0.48. This is one of some of the readings. Next slide, please. All right. Now coming on to some pie charts that we made, right? Pie charts of alcoholic pH. So now, like this pie chart is basically categorizing wine samples by pH levels, indicating that 89.1% have an ideal pH for red wine, which these range values usually range from like 3.2 to 3.6. The remaining 10.9% fall outside the range, which would imply a more pronounced tart or flat taste, if affecting quality perception. Next slide, please. Okay, now going on to the alcoholic content. How much alcohol were present in these wine samples, right? So we found out that 51.5% of the wines were classified as came under high alcohol levels. But what is high alcohol? High alcohol for our case, we took it as a value above 13.5% alcohol, like for red wines, right? Which is it comes from the literature, and 48.5% were showed up came up to be like low alcohol, which means below an alcoholic concentration of 13.5. And this data set basically provides a balanced representation, which is important in modeling the impact of alcohol on quality. You should know this, right? Okay, next slide, please. Okay, now coming on to the QQ graph. This is the most interesting out of all because here, right, this plot is instrumental in evaluating normality of our model's residuals, right? So ideally, points should fall on the red reference, which you can see, right? The red reference line. Most points surprisingly do in our data, right? Most do. But there's some noticeable like departure from normality in like the upper quantities, right? Upper quantities, while several points deviate significantly, especially beyond the two standard deviation of two, right? This marks basically a theoretical quantitative axis. And so, what's the implication of this? I really want to talk about this. So, this suggests that while our assumptions of normality was generally met, the deviations basically suggest that the model may be improved. It has chances to be improved, right? To address the influence of outliers or non-normality in the error terms. Next slide, please. Okay, now coming on to the ANOVA table, which is also quite important in terms of data analysis because here you can see like different types of ranges for what we had or should be observing, right? Okay. So here you can see a PR factor reading as well as like a DF. And then fixed acidity residual value and volatile acid. This basically helps us to like evaluate like how our data perform like and how good it is. Next slide, please, which is basically analyzing for the variance. Next slide. Yeah.
Okay, so on to now our key findings from all these charts that previously we just talked about. So firstly, we got the statistically significant variables. So that with that being said, those variables are fixed acidity, volatile acidity, citric acid, and residual sugar, which all showed strong significance in predicting wine quality, which is extremely important when tasting and having wine. Next up, we got the model diagnostics. So the normal QQ plot indicated, as shown before, that the residuals are approximately normally distributed with some deviations at the tails. Next up, we have the residuals versus the fitted values suggested constant variance of residuals with potential mild heteroscedasticity. And then for the variable distributions, the histograms revealed that many variables were not normally distributed. And lastly, the correlations with all of that being said is that we found that there's strong positive correlation between fixed acidity and citric acid. And lastly, that the quality showed a negative correlation with volatile acidity and a positive correlation with alcohol content. So now the conclusion for our presentation. So after conducting all these different graphs and analyzing it and coding it, we all learned a lot of things about wine that we didn't know before, and a lot about how we can use statistics and probability in order to learn a deeper meaning of what goes into making wine. And then the insights. So what we gained from this from this project was that we gained outlier influence. So we learned that the QQ plot revealed slight deviations at the tails, as I said before, which indicates that the outliers may affect the model integrity and should be investigated further. That the residual versus fitted values plot suggested potential mild heteroscedasticity, indicating a need for possible model adjustments or transformations. And lastly, variable distribution. The pie charts of pH and alcohol content categories show a balanced data set, but the scatter plots do not demonstrate a strong relationship between density and alcohol content. So this is just showing how not everything's perfect and there are some differences and variances, and that it can always be improved with more data, with more tests, and with more sample sizes. Furthermore, the significant predictors that the NOVA results highlighted fixed acidity, volatile acidity, citric acid, and the residual sugar as significant predictors of wine colorability, while the chlorides are not, and that the quality shows negative correlations with volatile acidity and positive with alcohol, suggesting that these aspects are key to sensory quality. So it's basically just showing how that those key assets were what the consumer valued the most in their wine. And then lastly, for data distribution, the histograms indicated non-normal distributions, pointing towards the potential benefit of non-parametric statistical methods in future analysis. And then with all this being said, how is it going to implicate and impact the future? So the first thing we came up with was the outlier analysis. So delving deeper into the outliers identified in the dataset could uncover unique patterns or abnormalities that warrant further investigation, potentially shedding light on exceptional wine characteristics. The second one we came up with was the advanced modeling techniques. So it was basically about exploring more sophisticated modeling approaches, such as generalized predictive models, or GAMs for short, or machine learning algorithms could capture complex nonlinear relationships and interactions between variables. Structural equation modeling, employing structural equation modeling, or SEM, could disentangle the causal pathways and provide a more nuanced understanding of the interdependencies among the psychochemical properties of the wine. And lastly, integrating sensory analysis. Incorporating sensory analysis data could also enrich the dataset with qualitative insights, complementing the qualitative rigor and offering a more holistic perspective on wine quality. And then that is all. I hope you enjoyed our presentation. If you have any questions, feel free to reach out to either one of us, and have a good night.